All right, Science 20. We're at the end. This is the last video of the course. Today, we're just going to wrap things up with a little lesson on the greenhouse effect. Let's just take a quick look. The greenhouse effect is something that we have talked about in society a lot. A lot of people have heard about it. A lot of people are familiar with it. We're just going to flesh out some of the fine details here. So, a greenhouse is basically a building, a structure that is constructed with certain materials that when sunlight shines through it, it will trap the solar heat energy, the thermal energy from the sunshine, and keep it contained within the building. That elevates the temperature of the greenhouse, which makes it a little bit warmer than what is on the outside. And this could be very useful for things like if you want to get a start on your garden early, you can get started in a greenhouse to start while there's still maybe some snow on the ground. Um, but it's due to this natural insulation. Now, the Earth's atmosphere has gases that work in a similar way, carbon dioxide and methane being two of the main ones that we focus on. Their job is to trap heat near the Earth's surface. This is good because it allows our planet to have a temperature that we can survive in. What we are what we want to avoid is getting a really cold uh, period, like colder than our coldest ice ages, basically without this insulation here. However, the issue is not so much that we have these gases in here; it's that we have added more carbon dioxide and methane and other greenhouse gases to the atmosphere, and that's causing potentially greater climate changes than would be happening naturally. Now, carbon dioxide in the atmosphere, the those amounts change fairly often, and they can change quite drastically. Volcanic activity releases a lot of carbon dioxide into the atmosphere, and we've talked about how volcanoes in the past have led to small climate variations within certain regions. But these variations due to volcanic activity seems to correlate with global temperatures over the last 160,000 years or so. Now, changes in carbon dioxide um, have amplified the effect on the atmosphere's temperature. So we have seen since the Industrial Revolution greater dependence on the burning of fossil fuels as a source of energy. We've talked about this in the past in the chemistry unit, but when we release large amounts of carbon dioxide into the atmosphere through these hydrocarbon combustions, that's enhancing the Earth's natural greenhouse effect. And therefore, we are experiencing a much more significant increase in average global temperatures during the last 100 years or so. And computer models are predicting that as our CO2 levels continue to increase, we will see an average increase in global temperature. Now, within Canada and especially within Alberta, we are contributing more carbon dioxide per person than other places in the world. That has a lot to do with our climate. We're a bit colder than other places. Um, and that possibly can lead to uh, more carbon dioxide in the atmosphere, and therefore we are causing more uh, more problems for everybody else. Now, as we take a look, the United States is absolutely right above us in the amount per person, but we're like kind of tied there with or statistically tied with Australia for second place. Uh, so the maximum allowance is what we want to try to bring we want to try to get down to here. this red line. That is our preferred level. We got a long way to, the planet has a long way to go. We definitely have a very long way to go. Now, here's a little interesting idea. Global change causes global cooling, or global warming causing global cooling. So this is actually something that is being predicted. Um, as the Earth warms due to the enhanced greenhouse effect, mountain glaciers and continental ice sheets melt. And we have seen like the Greenland ice sheet starting to shrink, and this releases fresh water into the North Atlantic Ocean. If the atmospheric temperature is hot enough, the rate of melting will increase. This will add more water to the North Atlantic, which can then slow down those warming tropical currents we talked about in the last video. That means less heat is getting pumped towards the poles from the tropics. This could have a rapid cooling effect on the poles, which could now result in advancing ice sheets in the north. And so this is just one of the many variables that kind of illustrates how Earth's climate is a very complex system. But I would say it's definitely given us cause to consider why or the wisdom in releasing large amounts of carbon dioxide into the atmosphere. If we can tone it down, if we can bring our CO2 levels down, the commonly held theory is that we will see stabilization in some of the weather patterns that we're experiencing. But anyways, that's it, ladies and gentlemen. We are now done this unit, done this course. So feel free to go back and watch these videos again. And I won't see you in the next lesson video. I'll just see you later.